Welcome to the 7th part of the Project Skylark House Generator tutorial series. In this part, we'll add horizontal beams below and above the windows. Let's add a couple of additional beams to this. So we've got the diagonal ones, we got the vertical ones, but we're lacking any horizontal beams. The most basic one that I would like to add is one horizontal beam at the start of each floor. Fortunately, this is pretty simple. Just move this over to the side slightly. We can just take this input right here and then use the clip node to get the bottom edge. So this clip will actually look very similar to this clip. So I'll just hold Alt and make a copy of this clip node. The only thing that will change here is this distance. Instead of linking it to the window height, we want to link this to the beam thickness. So right click, paste relative references. And let's also change this to primitives below the plane. You can see that our window beams have quite a bit of thickness. That's to aid with the Boolean. It works better if it's a solid bit of geometry. So let's do the same thing with this clip node. Let's just add a thicken node. Set that to both directions. We can use a depth of something like 1. It doesn't matter too much. The default values should honestly work quite well. And take that output and merge it back with the output of the match size. So something like this. And we can now have a look at the result of our Boolean, and we've got this bottom edge now. And just to check if everything's working, let's turn off single pass, or actually just look at the result of this loop. And you can see that it is working. We would still like to add a couple of additional beams in the middle, but that should be similarly straightforward. Inside of the window loop, let's add a divide node and connect that up with the input of our for loop. This will help with the non-planar nature of our mesh. The clip node will behave more consistently and give us a more predictable edge if we use the divide node. Just to show you what would happen if we connected that up with our existing logic, we would run into some issues, because if we look at this result, this bottom edge will now consist of two primitives. We could remove everything except for the very left and very right point, but there is not really much of a point because the assets that we're scattering have quite a big thickness, and any inconsistency with this edge doesn't matter too much. Although it does matter when it comes to the additional beams that we're placing, because we're using the clip node to get the edge and then making a rounded tube from that edge. We want to make sure that that edge is placed correctly on the non-manifold geometry. So with this divide node, we can just leave it at the default settings. We can even turn off maximum edges. Let's move this down a little bit. Now we'll use the clip node again. And I'll just make a copy of this existing clip node because we'll still be using the bounding box information. Connect the divide node to the clip node. And instead of placing these beams at the bottom of the whole wall, we want to place these below the windows. So let's take the output of this chain node, or the output of this match size, and then blast everything but the windows. So blast everything but the bounds, delete non-selected. So this will be our window essentially. Then inside of the clip node, we can use this lowest point as the point to place our new beam. So on the clip node, let's change the B box to -1. And we'll need to add a spare input, which will be this blast 2. Let's call this blast window height, and then look at the result of this clip node. We'll want to make sure that this clipped edges group is enabled. So now in the edge group to curve node, we can use that clipped edges group, if we just paste that here, to get this edge. So let's see what we've got. We've got the bottom edge, but the placement is not quite correct. We'll actually want to lower this based on the thickness of the beam. So let's type -0.5 times this current beam thickness value. And you can see it will be placed below. This is because we'll be sweeping this, making it a little bit thicker. Let's call this edge group to curve node bottom edge, and then add a sweep node, change the surface shape to round tube. And we can also enable end caps. Let's use grid. And let's try and merge this back in with all of our combined beam logic. We can see that that is mostly looking good, although our sweep also needs to be connected to the beam thickness. So right click on the beam thickness again, then here inside of the radius, base relative references, like this, and it appears it needs to be half of the thickness. You can see, however, that there's a side gap here between the beam and the window geometry, and we'll want a nice systematic solution to this problem. In order to make this a little bit more obvious, let's add some noise to the window placement. Let's enable single pass. So we're looking at just this wall. This will be single pass 2 in my case. And let's also make sure that single pass is enabled on this one. If we have a look at the curve that we're inputting into the chain node, it just consists of 2 points, but we can add some noise to the spine to make sure that each of the windows is rotated ever so slightly. Let's resample our mesh with the resample node. We'll do this right after the up node. Something like this will do. To add some noise to it, let's use an attribute noise node. Change the vector name to noise amount or something similar, and then this should also be a float and not a vector. Everything else can be left at default for now. Let's now apply this noise with an attribute wrangle. We'll be pushing our points up. To determine our up vector, let's define our direction, which will be derived from the normal. Just to quickly show you how this would work in a drawing, we've currently got our normal, which points out from the plane. So let's say that this is our mesh, something like this. We can take the cross product with the up vector, or just like 0, 1, 0, and you'll get this vector. And then if we take the cross product again, we'll essentially get this vector back, but it will be oriented according to this normal. So if our wall would be at an angle like this, because our normal points this way, first we get the cross product with the up vector, like the default up vector. We get this, and then this essentially defines a new plane which is perpendicular to the surface of the wall. So if we do the cross product again of those two, we'll get this vector. To do that, we need 2 cross products. So that will be cross of the cross product of the normal vector with the default up vector, which is just 1 in the y-axis, and close that off, and then use that output as the cross product with the normal again. Just close that off. That should work. Now we'll want to push our points in this direction by the noise amount that we had previously made with the attribute noise node. So we'll be updating the position attribute via p plus equals the amount, which is the noise amount, times the direction. And let's have a look at this result. We may actually want to change our attribute noise to be 0-centered instead of positive. We can also lower the amplitude a little bit to make it less extreme, something like this. If we now plug this into the orient along curves node, let's have a look at the chain node. We'll want to make sure that this mode here is set to deform between points instead of deform along curve. What this will do is just place the points onto the piece of the curve with the direction or with the orientation of the curve, instead of also trying to deform the geometry. So instead of deform along curve, we'll be deforming between the points. So that will just place these two with a slightly different angle. We can play around with the offset and you can see how our windows are being rotated. You can change the amplitude or even expose that as a user facing parameter. So let's have a look at our result now, and we'll actually see this issue be a little bit more prominent. We will want to make sure that this bottom beam actually follows the window placement. And we'll want to do the same at the top as well. So let's make a little bit of extra space for ourselves, and we'll add 2 additional groups to our window here. So we've currently only got the bounds, but we want a way to isolate just the bottom and the top faces. So just add a group node, call this one window bottom, and we can use the viewer state to select just the bottom face, hit enter, and then do the same thing, but this time for the top. So just hold Alt, make a copy, change this name to window top, and enter the viewer state and select this top primitive. And now here, inside of the clip node, essentially what we'll be doing is taking this bottom edge, resampling it, and then raying it to the bounds. Use the blast node and let's get only the bottom, and then delete non-selected. The reason why we need to do this is, as you might imagine, if you have this curve, or if you look at this curve and then look at this geometry, if you ray from this point here slightly to the left of the window, it might ray against the side of the window, which is not what we're interested in. We're only interested in it conforming to the bottom, which is why we need this unique blast node. We will need to calculate the up attribute similar to what we did before. Let's just check if it's available. Transfer attributes, if we just hold middle mouse button on this one, it is not, and that's because we're getting it from the input. That's fine. So I'm just going to clean this up and then copy that attribute wrangle in a moment. Let's call this attribute wrangle apply noise. Then just copy it and paste it after the resample. We'll need to make sure that we have this normal attribute. Currently we've only got the position, so we'll just add the normal node before our clip, or after our clip would also work, as long as it's before the edge group to curve node. Change the normal to points, and then on the edge group to curve node, transfer the normal. Let's visualize the point normals. We see that we do have them. Then inside of the attribute wrangle, remove this last bit and just assign this direction here to an attribute. We could say v at up, for example. That would work just fine. And let's visualize this up vector just to make sure that it does look correct, and I think it does. We can compare this against the input geometry. You can see that it does follow the non-manifold nature of the mesh as well, which is perfect. So call this attribute wrangle up. We will now need a ray node. So let's ray these points against the bottom faces of the window. And our ray node will want to change the vector that we're using. So direction from, change that to an attribute. And let's use the up attribute that we just created. So essentially this would work. However, you can see that not the whole bottom edge of the window is covered by this change. We would ideally also want this point to be moved up a little, and generally it doesn't really make sense for this entire bottom edge to remain flat and then only jump up just below the window. So instead of actually transforming our points here with the ray node, let's turn that off and enable point intersection distance. This will write to the @dist attribute, which we can transfer back to our points and then move those up. So let's add the attribute transfer node and take the output from the attribute wrangle and the ray into the second input. We'll be transferring the dist attribute, turn the primitive one off, and then in an attribute wrangle following the attribute transfer, we'll just push our point position into the direction of the up vector, which we had previously also used for the ray, so that's why this works. That would be v at up times the distance, so that would be @dist. So let's see what we get. And the reason why we're not seeing any difference here is if we look at our ray node, all these points here to the left, they will have a distance of 0, and that's also being transferred. So we'll want to only transfer the data there where there actually has been a ray intersection. On the ray node, we can enable the point group, the ray hit group. So now if we take a blast node right before the attribute transfer and only keep the ray hit group, and then look at this attribute wrangle, you can see that we get the result that we're looking for. Let's plug this into a sweep for now and see what happens. First of all, because we modified the up attribute here, this sweep node will no longer work as expected. So let's just add the orient along curve node right before, which will fix that issue. Let's call this attribute wrangle push to window, then align this all. Let's have a look at our result. So have the sweep node selected and also have a look at the window. You can see that it's clipping through. The best way to solve this is adding an attribute wrangle after our blast where we isolated the points hit by the ray, and let's remove a value from the distance. So take f at dist minus equals a channel float, which will be our beam thickness, divide by 2. Let's add this channel and let's link it up to our beam thickness. Now you can see that it's being pushed down. One thing that I'll do here in this attribute wrangle push to window is just add a small value to the distance to make sure that we don't get any issues with the Boolean later. So I'll be using a value of 0.05. I found that this works quite well. When I close this off, you can see that the whole beam is being moved into the window slightly. This will just make things work a little bit more consistently. Similarly, to help with the Boolean, what I'll do before the orient along curve node is just add a resample and then add a facet node. So this resample, first of all, will just add a bunch of extra points. I'll change this to 0.05. And what I'll then do with the facet node is enable the remove inline points option, which I'll leave at the default. We don't want too many points because when we do the Boolean later, if I have a look at the sweep geometry, if I disable the facet node, we'll get a bunch of points along a mesh, and that will be transferred onto our geometry in the end after the Boolean, which is just not necessary. So we can remove some of that with the facet node. But we do want this resample node with a lower length to make sure that it's accurate around these crucial bits. So let's have a look at our result now. It's looking quite good, and after the Boolean, you can see that it does now closely follow the window geometry, and we can disable single pass just to make sure that it's working everywhere. Let's have a look, and it looks pretty solid to me. Let's also disable single pass on this one. I think that looks good. Let's now add our top horizontal beam. I'll change our floor height to 3 just to make sure that we have enough space for the top horizontal beam. We can reuse most of this logic, fortunately. We will want 2 separate rays, one for the bottom and one for the top. So let's take this blast node and change it to window top. Let's just enable single pass again so we can have a look at the same example. Let's look at this. Let's see. I'll change the floor height back to 2 just so we get the same number for the debugging. So this is the example that we were just looking at. Let's plug the output of the blast window top into the ray. We will also want a separate clip node here, and because we'll need the normal for both of these versions, I'll just move the normal up to this one, then drag the second clip from that normal node, remove that normal. This clip will be set to Y max, and then let's keep everything above and change this thickness to be plus, or just remove the minus sign. In this case, we can see that these windows are placed too much towards the top, so that the top point of the window plus then the beam thickness will actually mean that this clip will be above this geometry and actually not keep any of it. So I'll just change this floor height again to something like 2.4. Hopefully that won't mess things up too much. And now we've got a little bit of extra space to work with. Let's move this over slightly to this side. We will essentially need the same exact nodes here, so I'll just copy these. After the clip, we'll need the bottom edge, which will actually be the top edge. So align these all, and then connect the clip to the edge group to curve node. And we can just change the name here to top edge. Everything else should be kept the same, although the up vector here has to point in the opposite direction. So I'll add a minus sign in front of the one, and then plug that into the ray node. Just to check that it's working, we can enable transform points, and that does appear to be correct. So turn that off again, then add a merge node after the ray here to merge the results of the 2 rays. I think that's looking good. And we'll also want to add a merge node before the attribute transfer, which would be this up vector. Now we can have a look at the final result again, and that's looking perfect. This should work very consistently. It should allow us to change the amplitude, increase it by a lot, something like 0.6 total. Even though our result here doesn't look great or realistic, at least the bottom and top edge do correctly conform to the window. Here you can actually see a case where a length of 5 for these beams is not long enough, so we might want to increase that. But let's just change this back to a sensible value, something like 0.2. Let's change our carve here, or the set carve attribute wrangle, to be a little bit more lenient and allow the windows to be placed a little bit closer to the edge of the wall. Something like 0.2 will suffice. And let's also change the spacing once again, something like 0.9. Let's stress test this a little by adding an attribute noise right at the start of our network here. change it to noise over the position, and then let's have a look at our final result. Set single pass to disabled. So in the attribute noise, we'll want quite a large amplitude and change the range value to 0 centered again. And basically, it just doesn't really break. There's one small fix that we can add in very rare cases, but I just want to make sure that we can actually catch this issue. I just want to show you in a separate file what would happen if the incoming plane is extremely non-planar, like this. The curves that we're generating might no longer fall onto the plane, and when we generate the sweep geometry and then boolean it with the actual mesh that we're seeing here, it won't intersect everywhere, and we can fix this by adding a few ray nodes. This is completely optional and you will probably not run into this issue, but I just wanted to show this in case you wanted to make the tool bulletproof. So we're just using the normal from these points where we left off to ray against our geometry. We divide this just to be sure, but this is the incoming geometry from the loop. We ray it in both directions. You can see the normal and the reversed normal. I create two groups for these just to make sure that they don't override each other, and then just keep the points that are actually on the geometry. You can see here, for example, if we have a look at this divided geometry next to it, this point does not lie within the geometry, so we'll remove it. And then to fix this edge as well, what we can do is first we get the curve U, and then only on the very start and very end of the curve, we fix the point position to the unshared edge, which is this edge. I've just created that as separate geometry with edge group to curve, and then using XYZ and prim UV, we can fix that point. So if I have a look at the before and after, you can see that that now perfectly lies on the curve. If we visualize those two together. And if we have a look at the before and after of our Boolean, let's change some of our single pass flags. And let's have a look at the final result here. You can get a sneak preview here at the window logic that we'll be adding shortly. Let's enable and disable that logic and you'll see exactly what will be fixed. So these beams here, you will probably not run into this issue though. In the next part, we'll work on the last beams on the side, the window extrusions, and a basement control.